So in this particular video, we have a system of 3 boxes shown here. Here's force F. That's going to push block A, B, and C to the right. The value of each box is given as in the statement there. Box A here has 20 kilograms. Block B is 30.5 kilograms. And then block C on the right has 46 kilograms. Okay. And it tells us in this particular problem, slightly different, that the force that B exerts on box C has a magnitude of 210. So rather than giving us this particular apply force, it tells us one in the contact force, which is between B and C, and it wants us to find the magnitude of the acceleration of the boxes. Part B wants us to find the magnitude F of the external force, or aka the apply force here on the left side, and C wants us to find the contact force that box A exerts on box B. All right. So if you need to pause, read it to yourself before you follow along here. I want to go and crack this out on this one slide. Okay. To find part A, it's pretty easy to do. Since it gives us the information here that the force that box B exerts on box C is 210. In the schematic here, the arrow that just came up is the force exerted from B onto C. So you notice here the arrow's starting at box B and it is pointing towards box C, because box C is going to move because box B is pushing it. So therefore I'm going to label that as force B onto C, and the magnitude of the force here is given as 210 in the problem. So again, typically the external force is given. In this one it's a little different. They give you one of the contact force, which is in this case is between B and C, which is 210, which is not bad. So you just have to learn to go with the flow for these types of problems based on what's given to you. Okay. So therefore, to find the magnitude, I want to focus my attention purely on box C, because the only reason box C is moving is because box B is pushing it. So in this case, the contact force given in this particular diagram is force B onto C, which is 210. Box B, therefore, is super easy to do because there's only one force in the horizontal direction. That's exerted from B onto C. Okay, so I'm just going to set up Newton's second law, which is FMA. But you notice here, I just put the net force here of block C, which is equal to mass of block C times the acceleration of the system, because they all accelerate at the same rate. But if you look at this particular diagram, the only force that's acting on C to cause it to accelerate to the right is the contact force from B onto C, which is given. So I will replace net force here with just a single force, FBC. Again, there is this net force, but there's only one force that's acting on block C. So I will go ahead and call it F of B onto C, which is equal to the mass of block C onto block C times the acceleration of the system. Here we know the force exerted from B onto C is 210, which is given to us. We know the mass of C, which is also given to us. And then the only thing we don't know is the acceleration of block C. Okay, so the question here in part A asks what is the magnitude of the acceleration of the boxes. So if you find the acceleration of box C, it tells you the acceleration of box B and A because they move as a single system. All right, so it's important to kind of recognize that. So therefore, in my work here, once you have these values plugged in, 210 newtons, which is equal to 46 kilogram times AX, we can just divide both sides by 46 kilogram in order to isolate for AX. So therefore, it's 210 newtons divided by 46 kilograms. And if you simplify that on your calculator, you should get about 4.56 meters per second squared. So here, that is my answer. And I'm reading part A again. It says the word magnitude. So therefore, the answer would simply be 4.57 meters per second squared, as the word magnitude would imply that you don't need to provide any sort of direction. Okay, let's crack out part B. Part B wants us to find the magnitude of this external force, or the applied force here to the system. Well, the applied force here is going to push A, but as a result, it's also going to push B and C, causing the system to accelerate to the right. So therefore, if I set up Newton's second law, net force here for the system is equal to M total times A. So my net force here for this diagram would only be one force, which is this variable F here on the left side of the diagram. So why it says net force here, I would encourage you to just replace it with what is applicable for each of the part. So if I'm looking at this diagram, the only force acting on the system is this force F. So net force would simply be just replaced with F. M total here is just the mass of the system, which is 20 kilogram, 30.5, and 46, which is given in the statement. And when we already found acceleration from part A, which is 4.57 meters per second square, and if you punch all this in your calculator correctly, you should get a applied force or an external force of about 441 newtons. And that is my answer. Once again, in part B, it says the word magnitude, so I don't need any direction here. But we know that's pointing to the right. So if you didn't use the word magnitude, you would just say plus 441 newtons, okay? Let's go ahead and crack out part C. Part C wants us to find the contact force that it's exerted by box A onto box B. So let's go ahead and clean this up a little bit here. Okay. So since it wants us to find the contact force between A and B, I'm just going to draw that arrow there. Since it's specified box A onto B, I'm just going to go ahead and draw this arrow from box A pushing box B. So that particular force, I'm just going to call it F of A onto box B. So that's what we're trying to find. So therefore, I encourage you to really kind of try to condense box B and C. So why there are two boxes, the contact force here is pushing B, but as a result, it's also going to push C. So here in my work, I've kind of replaced box B and C with just one box. So I can simplify the diagram down into two boxes. So you got box A, and then this box here that I've made transparent really is box B plus C together as one bigger block, okay? So the work that I have here is going to say that FAB, which is this diagram here, that I'm circling around, the cost of blocks B and C to move is due to this contact force FA and B. So here I have FA and B, which is equal to both the masses MB plus MC because it's pushing both those blocks, which I will treat as just a single block. The acceleration here is already calculated in part A, so therefore this is pretty straightforward to do. Block B is just 30.5 kilogram. Block C, which is 46 kilogram. Acceleration we have already, which is 4.57. So this is just calculator work. Here, in my answer, I highlight the plus sign because part C did not specify the magnitude of the contact force. It wants to find the contact force that box A exert onto box B, which in this case would be rightward because it's going to cause box B to accelerate. So that would be my answer. My answer would be plus 349.6 newtons. Okay, I hope that helps. Stay nerdy, don't be whack.